Hey everybody, let's walk through how to do switching for an RL circuit. So here we are on Multisim, and let me just draw something simple. So let's see, if you have say a current source and an inductor and then a resistor. So you have a circuit that kind of looks like this, and then let me just wire it. Okay, and then there is a switch. So you see here, switch. I'll just put a switch here. All right, so that's what it kind of looks like in the book, but that's not how we'll simulate, because you like turn the switch, close it, open it. That's not really how we want to simulate this thing. So let's, instead of using an independent source like this, let's use an AC source that looks more like a square wave. So it's basically timed, where it'll go up to some current and then turn off, then turn on, then turn off. So right here we have AC sources that could be a sinusoid or a triangular wave. We want a square. So I'm going to pick this clock current. So it's a current source that's basically a square wave. Okay, so let me just show you what that looks like. So let me wire this in here. Oh, let's see. Let me zoom in so you can see a little better. Okay, let me move this closer. Okay, so let me wire this in here. And for the simulation, I need a ground. Okay, so if I put my current meter here, let's see here, this is going to measure the output of my source. So if I'm just going to run over here, transient, so it's like 1 period's worth, or depends on what I set in the document. Okay, so let me arrange my screen. Let's see, I'm going to move my head over so you can see this side of the screen. Okay, now if I click here on the graph anywhere, and then see settings. So item would be settings for this graph itself. And then if I click over here where it says document, these would be settings for the simulation. So right now I'm simulating from 0 to 1 second. Okay, here. Okay, so let me go back here to my source. See over here on the left. Right now it's 1 amp, 1 kilohertz. Back on the right side of the screen. 1 amp in magnitude, 1 kilohertz is the frequency. What if I make it slower, like 1 hertz? So that means I will get 1 period of a square wave per second. And this duty cycle means like 50% of it is 1 volt, 1 amp, 50% of it is 0 amps. So that's the period. Okay, I mean, you can change it to like 80% of it is at 1 amp, 20% of it is at 0. So you can set this however you want. Okay, so let me run this simulation. All right, so right now I have the current source running at 1 hertz right here. And then if I click document, I'm running the simulation for 1 second. So let's say I run the simulation for 3 seconds. Then I will expect to see 3 periods worth of that square wave. Okay, and then if you click anywhere on this graph, see item, this right here, these are the properties of the graph. So let's say I want to zoom in to just look at from 0.4 seconds to 0.8 seconds. There you go, I just zoomed in. Okay. Now let's take a look at if we measure the inductor. So here I'm adding another probe to measure the current going through the inductor. Okay, so let me simulate that. All right, and let me change the value so that it's something more interesting. So I'm going to make this 1 Henry. And I'll make the resistor, let's say, 100. Okay, let's simulate that. There we go. Can you see? The green is the probe measuring the source, and the blue is the probe that's measuring the current going through the inductor. Now, let me zoom in. So I'm clicking here, just anywhere on the graph itself, and then item. Let me zoom in the x-axis. So let's say I'll go from, let's say like 0.49 up to 1 second. All right, so I just zoomed in. Let me zoom in somewhere in the x direction. So let's say to 550 milliseconds. You can type 550 m. That's the same as typing 0.55. Now you can really see that exponential decay. Right, so if the switch were closed for a long time, like more than 5 time constants, and then suddenly opens, then you see how the current decays exponentially. And let's say I wanted to measure the time constant. So how do you measure the time constant? You see here, so click anywhere on this graph, and then under item, you see here on the, with my cursor, it says cursors. So then you can go x-axis, and then here it says, what do you want to put the cursor? I want to put the cursor on probe 2. Cursor on probe 2. So you see how now these are blue as opposed to when they were on probe 1, they're green. And this measures the signal in the x direction as opposed to if you go here y-axis. See, now it's measuring the y-axis. And then you can also click track. It's like both x and y simultaneously. But I want to read the current going through the inductor. So I want probe 2, the blue one. So I'm going to switch this to probe 2. Probe 2. And this is really what a digital oscilloscope looks like. This is how you would use it. Okay, so let's say I want the time constant. I'm going to put cursor 1 right up here where it starts, where the switch opens. And then cursor 2, can you see way at the bottom here, the measurement here? I'm looking for 1 time constant. So that's when the signal drops to e to the minus 1. So e to the minus 1 is about 0.368 or something like that. All right, so I'm looking for 368 milliamps right here. So I'm going to move this cursor around until the current I'm reading about 368. Yeah, close enough, right? About 370 milliamps, 0.37. So you see over here, delta x. So the time interval is 10.04 milliseconds. So it takes 10 milliseconds for the signal to go from 1 amp to 0.37 amps. Right, so that's 1 time constant. So the time constant for this circuit is 10 milliseconds. Okay, so I hope that was a little bit instructive. Let me know if you have questions, and then keep practicing so you have more and more experience on Multisim. And I'll see you on the next video.